We should get started. Well, good morning, everyone. Let's begin. Let's do one of those find the first 5 values type of thing for a sequence. So this sequence is given as a formula, but it's got a factorial on it. So let's say I wanted to find A3. It would be -2 cubed over 3 plus 4 factorial. So the top would be eventually -8, and the bottom would be 7 factorial, which I'm not going to do from scratch. I'm just going to go 7, math button, all the way to there, and it's number 4. So there's 7 factorial, and it's 5040. Do you think that fraction can simplify just by looking at it? Because we should do style points. Shouldn't you always simplify things if possible? You think it's going to simplify?
Yeah, you can try by 2 at least.
Definitely, probably 4. But let's take the shortcut, hopefully. -8 divided by 5040 gives you a decimal. Then you hit the math button. Choice number 1, turn it into a fraction. And the answer is -1 over 630. Isn't that something you should do just in general? If you see a fraction and there's at least very big numbers in it, and you're pretty sure that it works, even if you're pretty sure it doesn't, because sometimes you get surprises. Can you imagine a fraction where the top and bottom might both divide by 17 and you'd thought, well, I never thought that would happen, but it does. So that's your result. I would make the assumption here, I think it's right. If I gave you a formula for a sequence, would you feel pretty comfortable about getting A3 or A42? Wouldn't it just simply be plug and chug? Right? I mean, now you know what factorials look like. There's really nothing too much to do. Let's do a recursive relationship. How about this one? We talked about that yesterday, the Fibonacci one, but in this one, the next term is described like that. And you always have to have a seed, in this case, the value of the first one. So if I want to get A2, it's A1 over 1 plus A1, that's 9/10. If I want to get A3, the next term, it's A2 over 1 plus A2, which is 9/10 over 1 plus 9/10. Now, since we always want our answers to be, in this case, fractions and as simplified as possible, I really don't want to have to do something like that by hand. And so I'll put a bracket around it and I'll go 9/10, so 9 divided by 10, close the bracket. Then I'll divide and I'll put another bracket and I'll go 1 plus 9 divided by 10 and close the bracket. Why am I putting brackets around almost everything inside here? Why are brackets helpful in a calculation that's a little bit messy like this one is?
To keep the terms organized.
Yeah, it's order of calculation. You know that sometimes you think you're asking it to do the right question, but if you don't put brackets, it does it in a different order and you get a different answer, which isn't correct. In particular, that bottom term, if I didn't have brackets around it, it would divide by a 9, and then it would add, or whatever, 10 to the answer. It would do some weird stuff. So when you hit the answer, you get that. And now I'm going to go math 1 and enter. And there you go, 9/19. Okay, one more. And the reason I'm doing this is I want to see if there's any, are these answers heading toward the limit or not? And it's going to be 9/19 over 1 plus 9/19. I'm going to do this one by hand. 9/19 on the top, 19 plus 9 is 28/19 on the bottom, and that one ends up being 9/28. All I can see here is that the top number tends to stay put as 9, and wouldn't the bottom numbers just get bigger and bigger and bigger? If I did a few more of those terms, I would probably come to the conclusion that the limit as n tends to infinity of this particular one would end up being 0. And my argument would go something like this, right? It's going to be 19, 28, 9/50, 9/, 102, eventually 9/1,000,000,000. If it kept on getting bigger, wouldn't the fraction become closer and closer to being 0? And that would just be an intuitive guess. I wouldn't guarantee that as a possibility. So let's see if my intuition is correct. Let's find out algebraically what the limit would be. And the first stage when you've got one of these recursive relationships is just to take the formula and imagine you're finding limits of both sides, and assume that this fella has a limit, and we'll call it L. And this fella, all of those guys are L. Remember, we did a an plus 1 is what, 2an plus 1, right? That kind of question, right? Yeah, it's a kind of algebraic trick, but isn't it kind of useful? What it allows us to do is to at least attempt to see it. Now, I want to solve this guy. How about a little cross multiplication? Oops, that's an L. Am I good or am I good? Do you see that L has to be 0 in this case if there's going to be a limit? I mean, that's a kind of nice little trick, isn't it? My intuition was, I think it's getting closer and closer to 0. At least that's what the pattern is kind of telling me. But doesn't this kind of prove it? Right? So if you want to solve it, now, not all recursive relationships like these have a limit. So what does it look like when the answer is infinite, right? Well, unfortunately, that's where this technique has a flaw. You may solve it and you may find out that you get a solution. L is 2, L is 0, L is 42, right? But the true answer might be that the answer just gets bigger and bigger forever. I'm give you an example. Fibonacci, right? Fibonacci sequence. En plus 1 is an, right, that one. Now, if I do the limit thing, would you agree that, cut out the middleman, isn't that essentially what you get? And what does that say? Well, if you do a quick one, doesn't that say L equals 0? Do you see you've got a limit? But Fibonacci sequence doesn't typically have that as its limit. But there is one exception to that. If you start off with 2 zeros, don't you get that as a limit? Because if a Fibonacci has 2 zeros, isn't the next number a 0 and the one after that a 0 and the one after that 0? So trivially, if you went to infinity, it would be 0. So what this technique does is it tells you a possible limit. So in this case, the limit of 0 makes sense. But if I chose a different seed number, this could end up being a sequence that gets bigger and bigger and bigger, right? In other words, it has no limit. So you have to be extra careful when you use this algebra technique to find the limit of a recurrence relationship, because it is possible that the answer might diverge to infinity. It will converge to the number that it says, but only in some circumstances. And for instance, in the Fibonacci sequence, it only converges to 0 when you start off with 2 zeros. If you start off with any other 2 numbers in the universe, it zooms off to infinity or negative infinity. That's kind of sneaky, isn't it? That it's a nice technique, but it doesn't always tell you the truth. Analogy. Doesn't L'Hopital do that? See if you use L'Hopital when you shouldn't, won't you get a number? It's just not the right number. Have you ever done that in L'Hopital where you actually did it one more time, you know, more than you should have done it? And, you know, L'Hopital only works if it's indeterminate form. I guess that's what I'm saying. Right, let's move on to a different kind of problem. Here is a sequence written down by just telling you the numbers in it. And we have got the problem. Our job is to find the formula. Now, there are many different sequences in the universe, many different patterns. So one size does not fit all. You have to look at the sequence in front of you and try and create a relationship. So this is my approach. I'm not saying it's a good one. I'm just saying it's the one that works for me, and hopefully it'll work for you. First thing I do is I recognize that when n is 1, the answer is in the 8th. When n is 2, the answer is 16. When n is 3, it's this. When n is 4, it's that. When n is 5, it's that. And then I look for things that stay the same and things that change. Would you agree that this is a fraction where the top is always 1? That stays the same. And then I look for a connection. And I look for, what could I do to the number 1 to get 8? And do the same thing to number 3 and get 24, and do the same thing to the number 5 and get 40. Can anybody think of what you would do to this number to get that number?
Multiply by 8.
Right, and to multiply it by 8, and two of you kind of said at the same time, wouldn't you write that down as 8n? And there's our first formula. Now, suppose I make this sequence alternate, not just what we call it when it goes plus minus, plus minus. Would you agree the top changes now, right? It's not the same number. But when something is alternating, it always has -1 to the power of something, right? And when a sequence goes plus minus, plus minus, plus minus, or maybe negative first, then plus, then negative, then plus, there's really only 2 guys in the world you need to worry about. One of these will generate that. Which one of these 2 generates this sequence?
n plus 1.
Okay, let's check it out. When you plug in 1, don't you only really need to check for the first one, and if it works, you know it's going to work for the rest. So in this case, n plus 1. I love these questions. It's just the brain. I love puzzles. So here's another one. -8, 16 over 3, -32 over 9. Making sure I got this again. 64 over 27. And -128 over 81. I know that isn't a fraction, but if I call it a fraction over 1, won't you agree that it's now the right guy? Okay. Definitely a fraction. Plus, minus, plus, minus, plus, minus, right? So you notice this one goes alternating, negative something, plus something, negative something, plus something, negative something, right? So when I say an alternate, which one of these two starts with a negative and then goes plus negative forever? Which one of these two generates this pattern of pluses and minuses?
And
Agreed. If you've got a good memory, if it starts with a negative, it's this one. If it starts with a positive, it's that one. Right. Now we get the fun part. And 8, 16, 32, 64, 128. 3, 9, 27, 81. Whoa. You get bonus prizes. Let's do the bottom one. 1, 3, 9, 27, 81. Can anybody figure out a pattern that's going on here? And therefore,
cube.
N cubed, 1 cubed, 2 cubed, 3 cubed. Oh, you're looking, no, not cubed.
3 to the n.
I hear a 3.
Multiplying by 3.
Right, so they're multiplying by 3. I agree. Would you agree? Times 3. We're doing the bottom one, by the way, not the top. So times 3, times 3, times 3, times 3. If you see the pattern that you just keep multiplying the last guy by 3, it's going to be 3 to the power of something. 3 to the power of n doesn't work. Because won't the first one be 3 and the second one by 9 and the third one would be 27? Do you see how you're out a little bit? But we can fix it. If 3 to the n doesn't work, let's pick a number. 2. 2 should get me the number 3. 3 squared is 9. You see, it doesn't work. But what could I adapt it to make it work?
N minus 1.
Sneaky. So if your thing is multiply by 5, multiply by 5, multiply by 5, your answer is going to be 5 to the power of n. And if you're lucky, that's it. But if it's not, it's going to be 5 to the power of n, add 1, 5 to the power of n, take away 1, take away 2, something like that, right? Now, the same thing is happening on the top. Do you notice that you're going times 2, times 2, times 2, times 2? Agreed? So I know it's 2 to the power of n. But it doesn't quite work, does it? The first number is 8, and 2 to the power of 1 is only 2. The second number is 16, but 2 to the power of 2 is only 4. Do you see we're slightly out of sync? What should I do to this n to make an 8 happen?
Add 2.
N plus 2.
Yeah. Do you see how a small innocuous question like this can cause so much trouble, right? Because of its, its nuances. But it's so much fun when you get it correct. You could rearrange this one if you wanted to and do some style point things, but I'm not going to.
Combine the negative and the 2, right?
Yeah, and pull out a 2 squared, which is 4, and do some stuff like that. Yeah. But to me, that's a good answer, so I wouldn't worry about it. How about this one? I hope you all notice something going on here. Do you notice that to get from one number to the next, you add 6? When you see a sequence where you continually add the same amount, and we have names for these are called arithmetic sequences. And it's helpful if you recognize that it's an arithmetic sequence, because it helps you get the formula. If you add 6 each time, the formula is always going to be 6n. plus or minus some fixed number. So plus or minus 2, plus or minus 4, whatever it ends up being. So the first number is 2, the second is 8, the third is that, and so on. So I know the formula at least has 6n in it. What I don't know yet is it plus 1 or minus 2? So the easiest way to decide is just pick randomly anybody you like. And for no particular reason, I'm going to pick 3. And so when I plug 3 in here, I should get the answer 14 if it works. Well, isn't 6 times 3 18? So I'll need to take away 4 to make that work. Well, let's check it out. If you plug in 2 then, does 6 times 2 take away 4 get you 8? Yeah. If I plug in 1, 2, 3, 4, if I plug in 5, doesn't 6 times 5 take away 4 get you 26? Do you see that you only need to pick any one you like to figure out what the add subtract is? Let's try another one. Let's do 1, 5, 9, 13, 17. Do you recognize that as an arithmetic sequence where you're adding 4 each time? Since you're adding 4 each time, won't the formula start with 4n? Okay, plus or minus what to make the thing finished?
-3.
Check it out. 4 times 1 should get me 1. Yep, we're finished. So if you have a sequence where you add the same amount every time, that tells you the multiple of n, right? It's going to be 6n, 2n, or in this case, 4n. These are called arithmetic sequences. The next one I'm going to show you is called a geometric sequence. In fact, the geometric sequence is much more common. I'll show you what a geometric sequence looks like. In a geometric sequence, to get from one number to the next, you multiply by something. In this case, you're multiplying by a half. And when that happens, you have what is called a geometric sequence. And the formula for a geometric sequence is a little bit more complicated. It's called AR to the power of n minus 1. A is always whatever the first term is. So in this case, the first term is 2. R is called the common ratio. And the common ratio just means what do you multiply to get the next guy? In this case, it's a half. So in our story, it's going to be 2 times 1/2 to the power of n minus 1. And if I wanted to make this a little bit prettier, I could write it in lots of ways. I could write it like this. I could write it like that. I could just leave it alone and write it like that. They're all the same thing. So when that happens, we call that a geometric sequence. Do another geometric. What are you multiplying in this sequence? This is a geometric sequence. What is the common ratio?
Three.
So according to our general formula, the geometric sequence looks like that. And won't that be 2 times, you have to kind of emphasize it a little bit, 3 to the power of n minus 1. Wasn't that very quick? Once you recognize that it's geometric, how to calculate its formula. Let's make it alternating. What's the common ratio now? What do you want?
-3.
Just -3. And so won't the only change be to do that? So alternating series, we are done. Try a totally different sequence now. 1, 9, -4/10, 9/11, -16, 12ths, and so on. Okay, what's one of the first obvious features that this sequence has? Anything you see that's pretty straightforward and obvious.
On the bottom, yeah, add 1.
Okay. Is it going to be add 1? Oh, you mean from this term to this term is add 1? Agreed. What's the formula for the bottom?
X plus 1, or that's not right, but
No, it's definitely 1, right? So 1n, because you're adding 1. But n plus what? 1 gets you 9, 3 gets you 11, 4 gets you 12. What would you add to this position, the 4, to get the answer 12?
n minus 1. No, sorry, that's not right.
Right, keep thinking, it'll come. What would you do to 4 to get 12? And do the same thing to 2 to get 10.
Oh, plus 8.
Yeah.
Sorry.
Right. Do you notice that this is alternating?
Yeah, I was
Plus-
wondering if you could divide it into 2 sequences that were layered together, or
Not
if
a
that's
good,
even not a good
not a
method.
good thing. Yeah.
Oh, okay.
Could you do it? Yes, but don't.
Okay.
Because you want a single formula for the whole sequence and not 2 separate formulas.
I gotcha.
That wouldn't be helpful. Right, do you see it's alternating? Is this an n or an n plus 1? Which one generates this combination of pluses and minuses?
N plus 1.
Agreed? Did you do that because you're just memorizing the damn things now, or you check it out? Whatever.
It makes
Right.
more sense to my brain to just say -1 to the power 2 and just figure it out each time.
Okay, now what I'm doing here is isolating the numbers now, taking out the negatives. Do you recognize 1, 4, 9, 16, and the next one would be 25 and so on? Because that has a pattern in it. And if it has a pattern, it has a formula.
They're perfect squares.
Right?
Or
In fact,
n-squares.
aren't they just an n squared, even better, right? Okay. Can you imagine another sequence of squares, but it went like this? In other words, it's what I call out of sync. Do you see that the first number was 9 and pretend that was 16? In this case here, everything matches up, so it's just n squared. How would we adapt for a sequence where the first number was 9, then 16, then 25, when something like this is out of sync?
That would just be n plus 2 squared.
Right. So sometimes you get a pattern, but it's kind of missing the first term or two, right? It's out of sync. And when that happens, don't you basically just add or subtract 1 or 2 and, you can sync it up. Have you noticed how different sequences can be, even in the short time that we've been dealing with this? Aren't there a lot of different sequences out there? And so if you're trying to create the formula, you really have to be good at identifying patterns. So let's look at a sequence. So we're back to formulas again. Let's look at that sequence. And I would be interested in seeing if there's a way we can find the limit as n tends to infinity. And I'm going to do it by brute force. What does a fraction like a half to the power infinity, right? As the power gets bigger and bigger, what does that become?
Smaller and smaller.
Right. Would you agree it disappears to 0? And so won't the limit be 1? How about this very similar looking sequence? If I find the limit as n tends to infinity this time, I have to ask myself, what happens to 1.5 when it to the power of infinity? What would that look like?
It gets bigger, but just more slowly.
But bigger
Stuff.
forever, right?
Yeah.
So it would be infinitely large eventually, right? It would take a long time to do it, but it would still make it. And we just call those guys diverges. Yeah, the answer's infinity, but we just say diverges. So if you have, I'll just call it a to the n. Maybe A is a bad choice. B to the n, right? So if I have a sequence b to the n, and there's other stuff there, but there's a b to the n in it, can we make the conclusion that if the absolute value of b is less than 1, it will converge? And if the absolute value of b is greater than or equal to 1, it would diverge. So if you're doing a half to the power of n, won't that go to 0? But if you do 1.1 to the power of n, won't that go to infinity? That's basically what I'm trying to say here. So you can do brute force on these guys, which are really kind of in the geometric series family. Now, what would it look like if you plotted a sequence? How would you sketch a sequence? So let me try a very simple one, because I don't want to do anything that hurts my brain. I would like to plot that sequence. And I am not going to make any attempt at being particularly accurate, because I just want the gist of it. Along this axis here, you put n. And along this axis here, you put the value of whatever en is. Right, so when I plug in 1, I get okay, I get 3 hearts just made it. So it's there. When I plug in 2, let me put in some of the other numbers. It's a half. Oh, I've changed my scale. Okay, can you pretend that was doing that better? Right. Now you plug in 2, you get 1 5/4. When you plug in 3, you get 1 7/8. And you plug in 4, you get 1 16, 1 32, and 1 64. And if I draw a little dotted line here, can you see that this sequence is essentially leveling off to 1? Would that make sense that the limit of that sequence was 1? So if you wanted to plot a sequence, don't you just basically plot a whole sequence of dots? Right? When n is 1, this is the answer. When n is 2, this is the answer. When n is 3, this is the answer. So you could get a sequence that looks something like this. Wouldn't that be a great indication that this sequence diverges? Would that make sense? So if you plotted it and you saw it getting bigger and bigger, it would converge. If it does this fella, would you agree that it converges, right? It has a limit. There is another possibility that can happen. Well, there are two possibilities, I guess, but one of them is pretty rare. Can you imagine a sequence where there is no particular pattern, it's just random? What could that look like? Especially if I allow it. Wouldn't the sign of n just give you random numbers between 1 and -1? So I should put some dots down here as well, right? Can you see that one has no limit? It's just random. The one I was thinking about is this can happen as well. Can you imagine a sequence where the answer alternates, but it bounces between two different answers? So the next answer is almost 2. The one after that is even closer to -2. The one after that is even closer to +2. Can you imagine one of those like bouncing balls between two walls? If that happens to a sequence, the limit as n tends to infinity of that sequence, we say that it diverges. Now you might say, wait a minute, it converges to two different numbers. Right? You might argue that you should say it converges to -2 and to 2, right? It goes closer and closer to numbers. But the formal definition of a limit is that it needs to converge to one number. If it goes off to infinity, we say it diverges, right? If it bounces between two numbers, we still say it diverges, right? So the only way you can be called a converging to a number is when there's only one number that it converges to. And that could happen with, hard to figure one out. That could happen, I just can't think of one off the top of my head. Any questions so far? So let's see what we've talked about. Arithmetic, geometric series. Do you recognize them when you see them, and how you can use little shortcuts to the formula? If it's any other sequence, isn't it just take what you've got and play with it, right? Look for patterns, try and figure out, you know, a formula that would come from that. Are we good? Right. Not that you get many, but if I asked you to sketch one, would you be able to draw a diagram of it, you know, from its formula, right? And recognize when it converges and when it diverges. Let's look at an answer to one of the questions from the homework. The reason I want to do an answer is because it takes a bloody long to do these things. If you go looking at Canvas, there is a video or instructions on how to use your TI-84 to find the values of a sequence. Can you imagine that this table here, where all the red numbers are the answers, right? They've been done for you. Would take you a long time if you had to do it by hand. Wouldn't it be nice if you could just get your calculator to just tell you all the answers, right? So it is possible, although a little time consuming. What I want to do is, let's look at this sequence here. If you look at these values, can you see that they bounce around a little bit? Would you also agree that they are foaming in on 1? Right? As n gets bigger, would you agree that this sequence of numbers is really getting dead close to 1? Right? It's like a damped oscillation. And there's some working for it. Now, if you wanted to do this one, you'll have to trust me on this one, but see if you take this sequence and you do the first 10 terms, what happens is it just gets bigger and bigger and bigger and bigger. So when you look at a table of values like that, and it's not getting closer to one number, it's just getting larger and larger, then you are looking at a sequence that will eventually be a diverger. And if you plot it, it ends up being that one. So you can decide, is a sequence converging or not by looking at its table of values and seeing if you detect any kind of convergence or divergence. So let's return back to what we did yesterday, and let's look at how to find limits and sequences. And we can do brute force. Nothing wrong with brute force, right? Basically make n infinity and see what you get. You can do L'Hopital. And you can do the divide, top and bottom. You know the ones where you divide the top and bottom by n squared or n cubed, that technique. So if I asked you to find the limit of this sequence in front of me, which is that one. Brute force would not work here. If I did this, can you trust me the answer is infinity over infinity and we don't know it, infinity over infinity. What technique would you use to find this limit? L'Hopital or divide top and bottom by something? What method would you use?
Divide the top and bottom by n squared.
Actually, that would be my choice as well. Can you do L'Hopital? And wouldn't it also work? So it's not like only one method will work, right? Both will work. Now, if you decide to choose that technique, you get 6 plus 1 over n, and then 3 take away 1 over n. And then essentially, don't you just brute force it? You always finish with brute force. And you get the answer 2. If I chose to do that same question, but using L'Hopital, it would look something like this. 12n plus 1 over 6n minus 1. And if I did L'Hopital again, because I'd have to, because when you put infinities, it's still indeterminate, I would get the limit as n tends to infinity of 12 over 6, and there we go. I don't know, but 6 of one, half a dozen of the other. Would you agree they're both pretty quick? You know, whatever one you prefer. How about this one? Now that one should scare you. Any suggestions? Not the method yet, because it's too early to do the method. Any of these methods, it's still too early. Any suggestions how I could rewrite this in a different form that might make it more obvious?
11 underneath.
Yeah.
Would you agree? Now, in this format, if you try to do L'Hopital, can you trust me that you really don't go anywhere, right? It just keeps on getting worse. You certainly can't divide the top and bottom by n squared or n cubed because there isn't any. But what I could do is call it that. Can you remember we did a question earlier today where a half to the n became 0 and 3 halves to the n became infinity? Remember those guys? Shouldn't I be able to do brute force on this now? What will 9/11ths to the power of infinity get you?
That 10 towards 0.
And there's your answer. If I turned it upside down, right, a different question. Suppose it was 11/9ths. Right, a different question. Suppose it was that one. What would you get?
It would diverge.
Infinity.
Right,
Yeah,
infinity, and
diverge.
so we say diverges. So do you see that just because something's written in a particular form doesn't mean that it's fixed in stone. Would you agree that it was helpful to rearrange it in a format that allowed us to use a, oh, I've seen guys that look like that before, and basically do a brute force on it. For the last question for today, I love these questions. These are so much fun. Tell me what to do to solve this one. I don't need to rearrange it. One of the three techniques that we've mentioned, brute force, L'Hopital, or divide top and bottom, one of those techniques will save the day here.
Divide the top and bottom by square root n.
Why did you choose, correct answer, why did you choose the square root n?
Because that's the only term with n in it.
Yeah, pretty much. If that had been 2n squared over n squared plus 1, wouldn't all of you say, yeah, divide the top and bottom by n squared? The minute it's not an n squared or an n cubed, but it's something weird, like a square root of n or a cube root of n, don't you kind of say, oh, that's not the same thing, I can't do that. But can you actually do this divide top and bottom by anything you like, as long as it works? Right? Now, if you do that, you now have 2 on the top, 1 plus 1 over the square root of n. And at that point, brute force takes over. Would you agree that 1 over the square root of infinity is just 0?
Yeah.
And 1 plus 0 is still 1. So you get the answer 2 and you are finished. So these are going to be your go-to guys. Brute force, you can just plug in infinity and you know what the answer is going to be. You might have to do some L'Hopital on it, or you might have to divide the top and bottom by something, and then go for it. Now, that doesn't cover everything, because didn't we have a situation where you had to do some algebra first before you could do any of these? So always be on the lookout for the ugly, weird ones and say, oh, I could rewrite this a different way and then be able to use one of these three methods. The one that comes to mind, remember that 9/11 to the power of n one? That would qualify under that category. Okay, last name and bye-bye. Last name for attendance, and I will see you tomorrow. We learned some cool stuff today. I enjoyed today. The day was full of puzzles. I love puzzles. Although I'm not so sure some of you like them as much as I do, but they are fun.
I had a question.
Sure, what you got?
All right, so on the geometric sequence, on the first one we did, I don't understand the style points, how you got the different forms for the answer.
Oh, have you got the original? I threw the paper away. Can you? Oh, wait a minute. Might have it up here. No, I don't. Okay, have you got it?
Yeah, so you had an equals 2 times 1/2 to the n minus 1.
Right, that one there. Right, and we just showed you different versions of that. So you want to know
Yeah.
where they came from. Right, so first thing I'm going to do is, I'll put it out here out the road, is that you can write this by separating out the top and the bottom. But 1 to the power of anything is still 1. So that becomes that guy. So I have 2 times 1 over 2 to the n minus 1. So that's where that version came from. Now you can multiply two fractions together, so you end up with that version, which I believe is the second one. Right, 2 times 1 goes 2 on the top, and the bottom is still that. You see that? Now what I'm going to do is I'm going to take this 2 and essentially bring it downstairs as a -1 power. And so I end up with 1 on the top and reduce the bottom. Let me show you what that might look like in long form. If you take a 2, right, which is here, right, how would I write that? I call it 2 to the power of 1. Isn't 2 to the power of 1 on the top the same thing as 2 to the power of -1 on the bottom? And then combining these by adding, adding these is where the n-2 came from. And so that one and that one, and now I've lost the guy. Well, that one, that's it. I think I've got all 3 versions. I don't know how pernickety WebAssign is on the style point form. It might be quite happy with the first version without doing anything to it. Actually, I'm quite happy with the first version myself. I mean, it's the answer. It's just a different, these are just different versions of that same answer. If you pushed me, isn't this one slightly more elegant because there's less going on? But that's about it.
Okay, thank you.
You are welcome. Catherine, you got a question?
Yes, it's from the homework on section 11.1, number 18.
18, let me find it. Right, my version might not be quite yours, so you can tell me what the change is. But it's whether it converges or not, correct?
Yes, that's correct.
So I have an n to the 4 over an n cubed. What do you have to finish with?
Minus 7n.
Okay, so if we're going to do the limit, oops, as n tends to infinity of this particular, mess, let's do it again. Let's do the limit as n tends to infinity of this hill. This particular question, right, works if you divide the top and bottom by n cubed. You have to choose the correct one, right, the same one in both. Now you might say, well, why did I choose n cubed and not n to the 4? Take, when you've got a choice, always take the smaller of the 2 powers. That's my advice.